Okay, let's start. So, just I will share my screen. I hope the screen is visible. Well, good evening all. So, welcome to the second week of live interactive session or problem solving session for the course of Geotechnical Engineering 1. The course instructor is Professor D.N. Singh, and I am Yogendra Narayanan. I am a PMRF research scholar. We will be taking these sessions every week on Saturdays 5 p.m. to 7 p.m. and the primary aim of this course or this session or these sessions are to make the learners accustomed with the concepts and help in approaching the problems or understanding the concepts and applying these concepts to solve several problems which will be useful in various aspects such as various competitive exams or even NPTEL exams. So, and also it will give a good familiarity with the subjects. So, and I encourage all the learners to attend these sessions and get benefited. So, with this, I would like to I would like to briefly uh, revisit the contents that has been covered in week 2 of this course. So essentially in this week the major concepts covered are the formation of soils and the geological classifications of soils and various modes of transport of formation of soils and several agents and how they play, and also different type of deposits, soil deposits and their characteristics. So with this, according to this contents, we'll be discussing some of the questions so as to revise the contents of this week. So with this, we can go into the session. So first question. So which of the following constituents of the soil are considered as contaminants? Which of the following constituents of the soil are considered as contaminants? Option A, intergranular cement. Option B, organic matter. Option C, dissolved salts. And option D, air. Any answers? Any answers?
Yes, this industrial uh, contaminants.
Okay,
Yeah.
those fall under which? Where do you think those falls among the given options?
Actually, I am opening my laptop. I'm not able to see all these options. Uh,
Okay, you you did not
right
connect
now,
the
I'm
laptop, right?
seeing it on mobile.
Okay,
Uh,
okay. So let me repeat the options. So first is
yeah, yeah, yeah.
intergranular cement. Option
Yeah.
B is organic matter. Option
Mm,
C is dissolved salts, and option D is air.
mm, Dissolve solids. Uh, no, I think no clarity.
So we have to eliminate the options. So what I would do is let us go by options by several options. So intergranular cement, if you consider, it is an intrinsic property of the soil, where not property, I would say, intrinsic component. So during which occurs during the formation of the soils itself. So either it may be uh, calcium carbonate cement, which are formed in lowest deposits, so which make them weakly cemented. And there are several cementitious mm, cementitious materials which bind the grains of the soil uh, during the formation itself. So uh, even silicate cements and carbonate cements uh, are such agents. So and B, organic matter, if you consider it as a broad perspective, then organic matter is also native to the soil. So it consists of several microbial and several living aspects, plants, roots, etc. And if you come to D, air is obviously a component which you cannot ignore. And when you come to option C, dissolved salts, here there can be two bifurcations. So dissolved salts can be due to the natural salinity that is present in the soil itself. So that is one aspect. But as you rightly mentioned, you are mentioning some industrial contaminants, right? If I'm not wrong. So those industrial contaminants mostly gets falls under this category of dissolved salts, which gets leached into the groundwater. So so among these options, the options given, so the most uh, suitable option will be dissolved salts, which has the potential to contain the contaminants. So the correct option is option C. Any confusions or any points you would like to add, or any point uh, you have some uh, you need some clarity? Think then it is we can go to the next question. Which of the following constituents of the soils are formed by the chemical weathering of rocks? Let me repeat it. Which of the following constituents of the soils are formed by the chemical weathering of rocks? Option A, primary minerals. Option B, organic matter. Option C, clay minerals. And option D, vapor. Let me repeat the options. Option A, primary minerals. Option B, organic matter. Option C, clay minerals. And option D, vapor. Any guesses?
I think C, clay minerals.
Okay, why do you think so?
Actually, primary minerals with can be formed with physical weathering, and organic matter with uh, some organism, uh, small microorganism they can produce. And but vapor is different, so the option left is clay mineral.
Okay. Can you name some examples for primary minerals?
Primary minerals.
You are saying, but you are right in that you are saying that it is due to physical weathering.
Yeah.
So, uh, wh- what does primary minerals mean, or and what uh, does any some examples
It's
comes
like
to your mind?
silica minerals.
Yeah.
Uh, mm,
Any other?
no, I don't remember actually. Uh,
Okay. So, as you mentioned, good example is silica.
yeah.
So, as and though let us go by options. If you take primary minerals, it is essentially due to the formation. It is due to physical weathering, and during physical weathering, the mineralogical composition does not vary much. So mostly primary minerals like quartz, uh, and uh, feldspars, etc., are primary minerals which are present, and they don't undergo various changes over the period of time. And if you take option B, organic matter, it is obviously it undergoes decomposition, and it is due to biological action, majorly due to predominantly used to biological action. And vapor is maybe the water converting to vapor, it is due to thermal, because the question says that the constituents of the soils. So all these are constituents of the soils. Vapor may be present due to thermal effects, and clay minerals as is formed due to the chemical weathering of the several primary minerals. So it is due to chemical action or chemical weathering. It may be hydrolysis, hydration, carbonation, uh, uh, sil- uh, and several types of reactions are there. So that is essentially the clay minerals are formed due to the chemical weathering of rock. I hope I am clear now. Any confusions or anything you want to get it cleared, you can uh,
No, it's
ask.
okay.
Okay. So moving on to the next question. Which of the following soil types exhibit predominantly cohesion? Option A, marine clays. Option B, aeolian sands. Option C, peat. And option D, kaolin. Which of the following soil types exhibit predominantly cohesion? Option A, marine clays. Option B, aeolian sand. Option C, peat. And option D, kaolin.
Okay. My guess is for marine clays. Okay, because marine clays means they are all always in touch with water, so water provide them a natural cohesion also, and clays have a cohesion. But this sand don't have cohesion, and peat and kaolinite may have cohesion, but because kaolinite is also a clay mineral. Peat is a fine material, so fine material usually have cohesion. But the more good answer I'm seeing is marine clays.
No, there can be multiple answers also.
Okay. But if multiple answer are there, so apart from Aeolian sand, all have cohesion.
Okay. So, as you rightly mentioned, marine clays are predominantly cohesive uh, because not only it is not due to the presence of water only, but the cohesive property comes only when there is presence of water. So, so uh, to the person who joined recently, so you can continue from this discussion itself. I hope you can see the slides. Are you able to see the slides? Okay. So now aeolian sands are purely granular material. So we can reject this option. So kaolinite is a clay mineral, and when we add water to it, it displays it displays cohesion. That is, uh, it is cohesive. So kaolinite is an option. Marine clays is an option. Peat, as far as is concerned, it is essentially due to decomposition of organic matter, and uh, uh, as far as cohesive properties are concerned, uh, uh, you may feel that peat has cohesion, but actually, as per soil mechanics, you will see what gives rise to cohesion in the further lectures. So, if that is taken into consideration, so peat is not cohesive. So, it will not display cohesion as per uh, the uh, as per the factors which gives rise to cohesion. If you consider, you will be learning it in the further weeks. So as far as these are known, marine clays can be any clay mineral, any kaolinite, montmorillonite, illite, anything. And the nature of cohesion varies with one another. So varies with the type of the clay mineral, but these clays predominantly are they constitute cohesion. Hope I'm clear.
Yeah, okay.
So moving to the fourth question. So which of the following mechanisms are predominant in granular soil? Cohesion, friction, both A and B, and D, adhesion. Which of the following mechanisms are predominant in the granular soils? Option A, cohesion; option B, friction; option C, both A and B; and option D, adhesion.
I think option B. है ना?
Okay. Okay.
Because cohesion in granular soil, cohesion is less, and adhesion is more in fine grained soil like clay. Okay,
Okay.
so there may be cohesion, but uh, usually the property is more the friction, not the cohesion.
Okay. Your answer is right. So it is predominant. As the question mentions predominantly, so the answer is friction. But we have to understand some situations uh, which considers other options also. So what do you understand by the difference between cohesion and adhesion?
Uh, Adhesion actually is. Both are the force between the grains. They kept the grains unite.
Okay.
Uh, but
Any other explanations
uh,
come to your mind?
no.
Okay. So, as you mentioned, cohesion and adhesion are attractive forces. But if you what the major difference between cohesion and adhesion is that cohesion occurs between two similar components. So, if you take two grains, it is uh, if there is an attractive force between them, then it is known as cohesion. Adhesion, if you take, it is complete attractive force between two different types of components. If you take water and it if you pour it and if you pour it in your hand, it get adjust. So if you the attractive forces between two different components is known as adhesion, and the two similar components are known as cohesion. And as far as granular soils are considered concerned, cohesion will be present, but as you mentioned, it will not be that much dominant. And in some cases where the granular materials are cemented, that is due to any external agents, so there is the cementation exists between the granular materials. As in the last week discussion, I have introduced you to microbially induced calcite precipitation. That is between two grains. The presence of some bacteria gives rise to precipitation of calcite, which acts as a cementing agent between the two grains of, especially in the granular materials. So, and in case of some type of granular materials like loess and there will be calcium carbonate that are present, but in a weakly manner they bond the grains together. So those type of special situations gives rise to cohesion in granular soils. But uh, as far as the predominant mechanisms of uh, deformations are considered, friction plays the major role. Am I clear?
Okay.
Any other questions from the other person?
Oh,
Mr. Lodi? If you are not speaking, please switch off your mic, because some background noises are coming. So since these videos are recorded and being and will be posted in public forum, so that is the reason. Please switch off the mic. So let us move to the next question. I hope my screen is visible and you are able to see the questions, right?
yeah, it's I'm able to see. Now I'm seeing on the laptop.
Okay, fine. Uh, Let us move to the fifth question. Sedimentation of suspended particles in the water bodies is guided by dash forces. Sedimentations of suspended particle in water bodies is guided by what forces? Option A, buoyancy. Option B, gravity. Option C, centrifugation. Option D, all the above. Any guesses or not guess? Any answers?
My answer is for buoyancy.
Okay.
Yeah.
The question might contain multiple options.
Yeah, because in water,
Because
uh,
the
the dense sediment will settle first. Okay,
okay,
so density is related to this buoyancy.
okay, but buoyancy is the reason for floating, right? Not settling, na?
No, whatever the reason for floating may be the reason also for actually gravity is a common reason to anything goes to the surface of Earth. Okay, but
Yeah.
here I see the more relevant is buoyancy
No, as
because
I said, these questions may contain multiple answers also.
so buoyancy and gravity both, but not the centrifugation.
Okay. So, so to understand this, we can draw the free body diagram of grain suspended in a water column or water body. So, if you take a water body and to consider this as a ground level, and we can consider a single grain uh, moving at a particular velocity along with the water column, right? So our focus is on sedimentation of suspended particles. So sedimentation is ideally it has to settle down to the ground level, right? That is the bed. uh, it may be either seabed or lake bed or river bed, any beds. So if you consider, if you draw the free body diagram, obviously this will be uh, a grain will consist will be weighing some weight, and gravity will be acting W, and above is Buyon's force, so which opposes the gravity. So the sedimentation of suspended particles and uh, also the velocity of the water, that also plays an important role. So if you take at a particular point in a river or something, in a river or any water bodies, so at a particular point we can observe a particular size of particles being settled. So that is due to the that that is partly due to the velocity of this water uh, flowing flowing across, along with the force of buoyancy and weight. So, but essentially the sedimentation, if we take sedimentation, the major forces that govern is the sedimentation is due to the interplay between the buoyant forces and weight. So option A and B are right. As far as centrifugation is concerned, it is when uh, it is not it is not relevant to the phenomena of sedimentation. Maybe it is due during motion it may experience centrifugation, but not during sedimentation. So the right option will be A and B. Hope I'm clear. Any questions or any thing you want to get it cleared, you can.
No.
Okay. So let us move to the sixth question. So now, which of the following properties might change during disintegration of rocks in the process of formation of soils? Which of the properties might change during disintegration of rocks in the process of formation of soils? Option A, density. Option B, mineralogy. Option C, texture. And option D, all the above. Which of the following properties might change during disintegration of rocks in the process of formation of soils? Option A, density. Option B, mineralogy. Option C, texture. Option D, all of the above.
My answer is for density and texture because it is disintegration means physical disintegration. So in physical disintegration, mineralogy is not likely to be changed.
Okay.
Yeah.
So, as you rightly mentioned, uh, disintegration, as actually, as far as this question is concerned, the nature of disintegration is not clearly mentioned. So if we consider it as a physical disintegration only, so then as you said, uh, density and texture will modify. Can you say why?
Yeah, because in disintegration means forming smaller parts.
Okay.
So the smaller part will have at some different density from larger particle. Okay, and
Okay.
texture will also in a new proportion of particle size, texture would be different.
So what do you mean by texture?
Actually, that much not clear to me. Uh,
Okay. So texture is uh, you can define it as a roughness or surface property. So how much rough it is, what shape it is, and what size it is. So those things come into texture, and how it is, uh, uh, whether it is rounded or angular. So these things come under texture. So as you say, rightly said, density. If you take aeolian deposits, they have they are very fine. Uh, as far as their sizes and everything is concerned. And if you take some colluvial deposits which are due to the formation of gravity or glacial till, their their nature of formation is different, even though it is due to disintegration of rocks. So density obviously changes, and texture, the live example or most common example would be the uh, the deposits of alluvial plains. So the and if you take several transporting agents, or uh, if you take residual and transported soils, and if you consider among the transported soils the several transporting agents, so uh, in between or among the transporting agents itself, the texture of the soils will vary. So if you take gravity, it will be of a more uh, coarser, and the sizes will be more, the shape will be more irregular, and things like that. And if you take alluvial deposits, they will be more rounded and uh, fine materials with varied sizes based on the region of deposits, and which is due to the several abrasion and attrition processes that it undergoes during its transportation through water. And similarly, aeolian deposits, which is due to air or wind. So obviously, these are the some of the situations where the texture get modified. And if you consider, uh, yeah, so pretty much that's it. So hope I'm clear. If you have any doubts, you can ask. Any confusions?
No, it's okay.
Okay. So now let us go to the next question. So which of the following is an example of disintegration of rocks through chemical action? So which of the following is an example of disintegration of rocks through chemical action? Option A, limestone dissolution in seawater, acid rain precipitation and reaction. C, crushing due to external loads. Option D, all of the above.
Option A and B.
Okay. So as you are right. So limestone dissolution in sea. Why limestone should dissolve in seawater? Any idea? When limestone dissolution will occur?
Seawater have some bicarbonate, maybe.
Okay,
Uh,
limestone is calcium carbonate.
yeah.
So how how do you see these things affect limestone?
Something like a weak acid H2CO3.
Okay,
So they have a role. Uh,
okay. And acid rain precipitation and reaction, it is obvious. So based on the acid
yeah,
rain.
it is similar to that one concept that limestone dissolve, but that is particular to limestone, and that may be common to some other also.
Okay. So one more interesting perspective I will give here. So, as if you have seen the lecture, sir would have mentioned that these limestone dissolution will occur under several at a particular pressure and temperature ranges. Uh, so, what happens is that, and uh, if you take as a ground level, and if you take a region where there is a limestone dissolution, and these are some there are some cavities that are formed. So now why this forms is that as you go deeper, what happens to the pressure
Pressure generally increases,
and temperature?
temperature also increases.
And what about salinity?
Uh, I'm not sure about salinity changes.
Actually, if you consider depth with depth, there is a pressure gradient. So with depth, particular it will increase at a particular pressure. For example, 10 MPa per kilometer or something like that. And temperature, there is also a temperature gradient which varies from place to place. And there is a term known as salinity gradient also. And salinity gradient is some so it is a natural it is a fixed extent, but there might be several other reasons for the formation of salinity also. So now if you plot, so why limestone should dissolute? Because as you mentioned, there is some presence of acid, right? So acidity is defined by which parameter?
This is pH value. So pH value should be less than 7.
Yeah, so it is defined by pH. So one interesting aspect is that at a particular pressure temperature conditions, so if you take saline water, saline water, we define the salinity in some either gram per liter or mole per liter, etc. So one interesting aspect is that with press at a particular pressure temperature condition, pH starts decreasing with salinity. And this due to this aspect, there might be some of the uh, there might be some of the isolated places where these minerals get dissolved. So and you can also ask, then all the material should get dissolved, why it is not happening? That is the natural question which comes, right?
Yeah, because they limestone or any other rock may have joints. So along the joints, the water goes, and from the joint they start this caving.
Yeah, this caving occurs by if by that logic we go, entire formation should have dissolved, right? Why it does not happen? Why certain portion only gets formed due to this? So one of the possible reasons is that, so when if you consider any acids, uh, and limestone is essentially what does it constitute of? What does limestone constitute of? What is the mineral?
CaCO3.
CaCO3, right? So it is CaCO3. So when it reacts with some acids, so the what happens to the power of the acid as the reaction proceeds, or what happens to the while when it starts to dissolve, what happens to the uh, power of the acid to dissolve? Are you able to understand my question?
Yeah, but I can't answer that.
Okay, so what happens is that as if you consider uh, the dissolving of CaCO3, so as the reaction progresses, the pore solution will be more will get less and less acidic. So it will almost get inert to the mineral itself. So that is why that is one of the reasons there might be isolated patches of these cavities which results due to the limestone dissolution in seawater. So it is just for your information. And mm, yeah, any confusions?
No.
If you feel that any you are not clear, or you have any other inputs or any other views, you are welcome to create a discussion on it. So in that way it will be beneficial for both the parties. So as far as this question is concerned, A and B is the right option. So presence of what makes the lowest to be weakly cemented? Presence of what makes the lowest to be weakly cemented? Option A, NaOH. Option B, calcite. Option C, calcium bicarbonate. And option D is hematite.
Can't say anything.
So, but we what we know is, we know that loess are weakly
But
cemented, right?
two options I am not in favor. That is calcite and CaSO3 because they are related to mostly limestones. But losses are there are sands mostly.
Loess are
So
sands, but
yeah.
the major but the crux here is the cemented, the word cemented. right? The word cemented. So it need not be sands which acts as cementing agents.
No idea.
Actually, the answer is calcite. So
Okay.
in especially lowest deposit, if you consider, so the major cementing agent which makes it weakly cemented is calcite. And in case of sedimentary rocks which are formed very deep in the earth, so there you can find both calcite cement as well as silica cement. So if you take two grains, there will be a cementing agent which bridges these two. So it can be either uh, silica cement, it can be either carbonate cement, which is calcium, or magnesium, or it can be, in some cases, it is clay also. So, but since the question is pertinent to lowest deposits, the lowest deposits are characterized by weak cementation, which is due to the presence of calcite. I hope I'm clear.
Okay.
So, moving to the next question, which of the following sentences is not true? Loess are wind-blown deposits. Loess can stand in the form of steep slopes. Presence of calcite in the loess makes it less suitable for construction activities. Loess are predominant in the arid and semi-arid regions. Which of the following statements are not true regarding
I
loess?
think option B, Loess can stand in form of steep slopes.
But as we saw, loess are weakly cemented, right? Why it cannot stand in steep slopes?
No, weekly. Uh,
Any answer or any logic for that?
no,
You
no.
can say freely. So it is just a discussion. It is for the sake of discussion. If you have any logics, you are welcome to put forward.
No, no logic.
Okay. So actually, loess are the peculiar characteristics of loess are they can form steep slopes. So they are able to withstand or they are stable at steep slopes. I will not say stable, but they are capable. And essentially, they are wind-blown deposits, and they are found in arid and semi-arid regions. The the major option which we have to concentrate is the presence of calcite in the loess makes it less suitable for construction activities. So construction activities, in the sense, if we consider aggregate it as an aggregate or anything, so we are uh, uh, what does concrete consist of? I hope all are from civil engineering branch, right? So it is cement, fine aggregate, and coarse aggregate. So here, fine aggregates and coarse aggregates are bonded by cementing agent, which is cement. So, and if the aggregate itself contains some cementing properties, it is more suitable to consider it. So that is why they are also considered for uh, construction activities. So the critical point is the presence of calcite actually makes it favorable for construction materials, to qualify it as a construction material.
Okay.
Hope I'm clear. Or any doubts or any clarifications are required?
No.
Now, coming to the 10th question, which of the following minerals lead to swelling and shrinkage of soils?
This is Montmorillonite.
Okay, so I right now then I will extend the question. So swelling and shrinkage, why does not it occur in other clay minerals, or it occurs? Montmorillonite is a clay mineral, right?
Yeah.
So is halloysite and kaolinite, right? So calcite, it is we can it is a no-brainer. We can remove that option. It is not a it does not cause any swelling and shrinkages. So swelling and shrinkage are properties of clay minerals, and but you mentioned that whatever you said was right. So Montmorillonite is it predominantly leads to swelling and shrinkage. And uh, what about halloysite and kaolinite? Do they swell, or n- uh, do they swell and shrink, or they don't, or the magnitude is smaller?
Yeah, I think that they swell, but the magnitude may be smaller.
Okay. So any reason for you to say this statement?
Because they are clay minerals, so uh, in contact with water, they have minor, very minor swelling.
Okay. Okay, what you said is right. They do swell, but not to the extent of Montmorillonite. So the reasons you will be studying when the course comes to the stage of clay minerals and uh, soil water interaction, the chapter. So you might not understand it now, even if I explain it. So actually, the swelling and shrinkage of soils here. Uh, why the answer is only Montmorillonite? So that is what we need to understand. So the question is uh, intended towards the fact that which of the minerals that is the mineral leading to swelling and shrinkage causes predominant effect on the uh, on whatever action or whatever uh, activities which are being carried out by us. So even though kaolinite and halloysite do swell for to an extent, but they don't have that much significant effect. So that is why the more suitable answer is Montmorillonite. I hope I'm clear. If please switch on the mic when you are talking. So there are some background noises. Uh, as I said before, also. So since it goes to the public forum, and also it will be uploaded in the NPTEL website also in you can access from your account also for for further references. So it will be better there are no any uh, noises so that the recording can be clear. So moving to the next question. So which of the following is or transported soils. So aeolian soils, marine deposits, volcanic soils, D. Muskeg. So
Uh,
the question might contain multiple answers also. So keeping that in account, you can uh, say your answers.
Aeolian soil is transported soil. Uh, Volcanic soil are not that much transported, only within a locality of this volcanic source.
Okay.
Marine, marine is also transported,
Okay.
and I can't say. I don't know this musket. What is this musket?
Okay. So uh, please just hold on for a second. I will be back in a minute.
Yeah.
Uh, Sorry for the interruption. So please hold on for a second. I will be back in a minute. Uh, So, 11th question is which of the following are transported soils? So as now we can go by options. So first, if you take aeolian soils are due to wind. So these are obviously transported. And if you take B, marine deposits, those are also due to water, which are formed in the coastal areas as well as at the uh, point where river meets the seas. So nearby those areas are marine deposits, and volcanic soils are also to an extent transported due to volcanic activity. So
It comes under gravity, sir.
yeah, it is partially under gravity as well as
Eruption.
eruption. So we cannot it is a how to put it. So it cannot be uh, it is not that much transported, but to an extent it is transported.
But the media is gravity only, most
Yeah,
probably.
it is predominantly, if it occurs, it is due to gravity. And uh, Do anyone have what is known as musket? Any idea?
It is organic soil, waterlogged area. You are going to see this type of soils, decomposition of wood and fibers, plant residue, and all together.
Yeah. So, to give a better clarity, you must have heard about bogs. So, those are swamp areas. So there are predominantly organic, decomposed organic matter, and which have no proper drainage conditions. So those type of areas are those type of deposits uh, are known as muskeg. So these deposits are heavily organic rich, and they are completely or waterlogged to a maximum extent, since there is no proper drainage uh, conditions for the water to flow. So some it will be like, we can, to an extent, it is like a swamps, and you can say bogs also. So very loose deposits, uh, completely submerged in water, we can say. uh, so you have some idea about swamps, right, which are near coastal areas? Mangroves, swamps.
Is organic soil also comes under the same, sir? Other than muscus, it is also organic, but
Yeah.
normally peat or any other material also comes under
uh,
non-transported soils. Sir.
yeah, so those are essentially due to decomposition of organic matter. So those since these deposits are, they occur at that place itself, those are
Yeah.
predominantly residual.
Yeah.
So but based on the several other external phenomena, like the as you consider this example, muskeg. So they are characterized by the presence of large amounts of water, and the decomposition might not be the varying degree of decomposition due to presence of this water and external agents. So that is the only difference. But uh, these these soils are broadly classified as organic soils only.
Okay.
So the correct options as far as this is concerned, except muskeg, all are transported
Transport.
soils to an extent, uh, at least to an extent. So next question is, soil in marine deposits are contain only inorganic matter, or low in moisture content, or insensitive, or highly compressible. Soil
Option
in
D.
marine deposits are characterized by contain only inorganic matter, or low in moisture content, insensitive soil, highly compressible.
Option D, sir.
Okay, so but we can come by options. We can discuss all the options one by one. That will be good for comprehensive understanding why other options are not suitable, or why those characteristics are not applicable. So as far as option A is concerned, contain only inorganic matter, it is straight away it is an obvious answer that marine deposits contain some marine organisms, or nearby uh, those
Aquatic.
estuaries, aquatic lives, which will be obviously after their lifespan get decomposed in these and become a part of this ecosystem. So hence marine deposits are also very predominant. And if you take for example, dredging that is being carried out, those dredged materials are marine deposits and they contain predominantly organic matters. So this option is uh, not does not uh,
Correct option.
uh, characterize the that it does not uh, it is not a property of marine deposits. So are low in moisture content. As you can see, the people from coastal cities, you can see that if you uh, start excavating for any infrastructure projects, so the water table is fairly higher uh, in these marine deposits, near the marine deposits. So obviously, the more majority of the marine deposits are subjected to very high moisture contents. So and continuous exposure to these high moistures. So that is so hence this option is also not suitable. And insensitive soil. So insensitive soil. So uh, we have to define a property known as sensitivity of the soil. So the exact definitions you will be studying a little later. So to give a brief idea, so sensitivity is a property by which uh, a soil loses its strength properties upon disturbance, or the strength of the soil may vary upon disturbance. So that is sensitivity. So as these marine deposits contain various salts uh, among the grains, so when you disturb the soil, they get deformed in their strength properties vary to a drastic extent. So that is the major issue which the infrastructure in the coastal cities faces. So if you take for example Mumbai, so most of the deposits are marine clays which are highly sensitive. So if you just touch the soil, then the entire arrangement of the soil grains get disturbed. Sorry, so there has been a small network issue. So I will share the screen. So hope my screen is visible now.
Yes, sir.
So
Yes, visible.
so now since these as I was mentioning, if you take a city like Mumbai, so those are predominantly they are comprised of marine deposits, marine clays. So in those conditions, when you disturb a soil to a very small extent, the entire thing collapses. Entire the arrangement of the soil collapses, and it is completely uh, to
है
to put it in a
अर्जेंट नहीं तो बाद में करते हैं, क्लास में है ये, सुनता है।
please switch off your
बोलो।
mic.
एक मिनट, एक मिनट।
So in those cases, just a minimum disturbance will cause the entire collapse of the arrangement of the soil. So which leads to the change in its strength. So hence, uh, since the marine deposits are characterized by this property, they are not insensitive; they are sensitive soils. So these are also uh, this option is also not right. Highly compressible. As I said before, since the it's more sensitive when you apply external loads, so and also due to the presence of organic matter and the further decomposition of organic matter, uh, the amount of compression that it goes over, either uh, it may be immediate as well as over a period of time dependent compression. Both are fairly high in marine deposits. So the right option is are highly compressible. I hope I am clear. Any doubts or any clarifications or anything you want to uh, uh, get it more clearer, then you can ask. So then we can go to the next question. And question 13 is, bentonite is a material obtained due to the weathering of limestone, quartzite, volcanic ash, shales. Bentonite is a material obtained due to the weathering of limestone, quartzite, volcanic ash, and shales. Any guesses or any answers?
It may be maybe limestone or shale.
Actually,
C is volcanic ash.
the right answer is volcanic ash. So volcanic ash, it gives on chemical weathering, it gives more finer, because the reason is that bentonite is a relatively uh, finer material. So if you take volcanic ash, ash is already finer, and further weathering gives to this more finer material. So bentonite is product of weathering of the volcanic ash. So, and it has a very peculiar property, so which we'll discuss a bit later. Uh, Now moving to the next question, which of the following soil is or transported by gravitational force? Which of the following soils is or are transported by gravitational force? Option A, loess. Option B, talus. Option C, drift. Option D, dune sand.
Tell us.
Okay, what do you mean by talus?
At the slope, at the down of the slope, some material got detached and it deposited.
Yeah. So it is not at the bottom of, it get deposited at the bottom of the slope, but these are components which come or which get disintegrated at mostly the steep cliffs or steep slopes. So if you consider a steep slope like this, so these materials which get detached uh, and falls due to the effect of gravity, so these are known as talus. So and loess is essentially a wind. It is due to wind, uh, and dune sand is also due to wind, because if you go to some regions in Rajasthan, you will see a dune in one at one time, and the dune will be completely shifted to other position uh, over a period of time. So that is also due to the action of wind, and drift is also similar. So the option is which of the following soil is are transported by gravitational forces? Talus. Hope I'm clear.
Sir,
Yes.
landslides and avalanche both will comes under this only.
Those will come under a broad umbrella of colluvial soils, but if you take only talus, so those are essentially from the cliffs.
Cliffs, okay. Cliffs,
Yeah,
cliffs comes under vertical,
yeah.
but
So
landslide avalanche will be inclined. But both are
inclined.
gravity only.
Both are gravity. That's why I mentioned both comes under the colluvial deposits only.
Okay,
So
sir. Okay.
if in that there is a subset of talus which is essentially from cliffs.
Mhm.
I hope I'm clear now, right?
Yes, sir. Yes, sir.
So moving to the next uh, question.
Do
So
you have example of talus, sir, in India?
uh, no, these there is actually uh, actually I have not much idea about where it is found in India. Maybe I can find out and
Okay.
tell you.
Fine, sir.
So
Fine, sir. Thank you.
then moving to the next question. Lowest deposits are formed by vertical deposition of glacial till, chemical weathering of residual deposits, physical integration of rocks, and constant flow of wind in the same direction.
Option D.
Okay. Any other options?
Yeah. Better answer is D only, sir. But I am not sure about one direction or multiple directions. First time I am seeing the direction.
Okay. So, as you rightly mentioned, it is the constant flow of wind in the same direction. So, because loess are found in arid and semi-arid regions, and they are aeolian deposits. So, and one aspect could be physical disintegration also. So, because wind blowing at a very high velocities may uh, uh, if you consider a raw uh, uh, deposit of rocks, so when wind blows at a wind carrying a finer particle blows at a very high speed, so for example during sandstorms and things, so they will further disintegrate and deposit. So the option could be C and D.
Sir, small doubt, sir.
Yeah.
Option C, I don't know. I may not properly agree. The reason is
Hmm.
physical disintegration of rock means here we have a variable size of the particle starting
Yes,
from the boulders to the clay.
yes, yes.
Whereas the loess is a small size particle, it may not come exactly under the C option.
Yeah. uh, this is a good point that you have raised here. So actually,
Yes.
uh, the if you take it at a broader sense, so initially uh, there are two aspects. One is that it gets disintegrated at a particular place and get carried away by winds also, right? So that is essentially what happens. So the portion which you have mentioned is that where it gets disintegrated from the rocks and wind carries it further, right?
Yes, sir. But same thing. Once again, what I am asking is in
Yes.
physical weathering,
Mm-hmm.
we get of variable sizes.
Yeah.
After further weathering, bigger became smaller, like that, reducing sizes, and finally, wind is going to carry only by segregated part of only fine particles.
Yeah.
It
So
cannot carry all.
now what happens is that when wind
Hmm.
carries these small particles,
Hmm.
so small particles which are getting carried out by wind, may come into contact with further particles, which makes it which continues those process, right? So similar to when these particles get carried away by wind at a very high velocities, so there are some possibility where these high these grains which are carried at high velocity may come in contact with other grains,
Sir, in
which
that
will
case,
which
option B also you can check it, sir, once. See, physical weathering produces initially bigger particles.
yeah,
After bigger particles forms due to the climate, due to the acids and everything, that also further reduces by chemical action.
yeah.
That means here
Hmm.
the chemical weathering also indirectly part of the physical weathering, no?
Here major issue is in chemical weathering there will be a change in the characteristics itself. So there will
Yeah,
be a
minerals
change
and
in
everything will change.
mineralogy and those things also will change. So that is where
Sure.
the chemical and physical weathering gets altered, gets
Yeah.
differentiated.
Yes, sir.
Uh, so
Understood.
so now I think hope it is clear now, right?
It is clear, sir. But is the answer C also will come under this?
No, what I mentioned was the most favorable option is option D only.
Okay,
So,
fine.
as a broader sense, this is due to the result of this physical disintegration also.
Right, sir. Finally, my once again the question here is it MCQ or multiple select questions?
So, actually, this I'm not sure.
Hmm.
So, this
It-
I think it is MCQ, only one option.
In
So,
that case, D option.
in that case, it will be D,
Okay, if it is
obviously.
a
MSQ, then
multiple
C is
select
D.
question,
Yeah.
okay, okay, clear, sir. Now it's clear.
So, moving to the next question, the collapsible soils is associated with collapsible soil is associated with. It is a MCQ. Uh, A. Loess, option B. Ward, option C. Laterite, and option D. Black cotton soils.
Option A, sir.
Yeah. So the collapsible soils are loess also because they are weakly cemented. Uh, Option A. And most problematic will be black cotton, obviously. So due to their swell strength properties. So, but if you consider other options, what is what is warped clays?
Stratified deposits, sir.
Yeah, stratified deposits of.
Silt and clay.
Why does it occur?
These occurs in lakes due to the seasonal changes in water with
Yeah,
respect to climate.
because these occurs, and also as you rightly mentioned, it occurs when there is a drastic seasonal variations, and in that case, when more the seasonal variation, more the drastic seasonal variation is, the variation in the size of particles also varies accordingly, right? So So warped clays, as far as warped clays are concerned, they are layer deposits of alternate deposits of silts and clays, which are due to the seasonal variations. And lateritic soils are also, to an extent, very loosely deposited, or I would say not deposited, but they are very difficult to handle in case of construction. So, but the more suitable will be lowest. Uh, I hope it is clear, right? Any doubts or any?
It's clear.
So moving to the next question, which of the following present in the soil is most helpful to the growth of plants? Which of the following present in the soil is most helpful for the growth of plants? It is a multiple choice question. Only one answer. Option A clay, option B silt, option C humus, option D small porous rocks.
See, sir.
Option C, humus.
So where humus is found actually?
Forest area, thick
Forest area, but
forest, high rainfall.
yeah. So let me put it in a different manner. So generally, what to how much thickness or what? As far as from the point of view of agriculture is concerned, it is the soil is classified as topsoil, and further some classifications are there, which I'm not sure that much. So
Yeah,
the humus is predominantly found in topsoil,
topsoil, topsoil.
which is more uh, critical for the growth of plants, which usually varies up to 100 mm. That is some very top layer of soil, which are which contains high organic matter and highly nutritious for the growth of plants. And so since and hence humus is the major component present in the soil that facilitates plant growth to a large extent. So apart from that, uh, mineral sources may act as may facilitate mineral sources from clays and silts can facilitate, and presence of clay also facilitates because of its water holding capacity to an extent. So but the most predominant option is humus.
Sir,
Hope it is clear.
can I ask a small clarification, sir?
Yeah, yeah.
Regarding this humus,
Mm-hmm.
theoretically, we learn many places and many situations about what is the humus.
Mm-hmm.
In geotechnical engineering in laboratory,
Yes.
other than liquid limit test, do you have anything else to identify the soil is humus related or non-humus soils?
So as you mentioned, based on this liquid limit from A-line chart, you will get this. You can classify as organic soils, right? So humus is
Hmm.
essentially organic matter. So
Hmm.
one of the major tests which we consider to determine this is uh, the organic content and ash content. So what we do essentially is we take a particular amount of sample, uh, and we will fire it at 440 degrees centigrade.
Hmm.
So in that case, uh, the presence of organic matter completely is wiped out. So you will get exact only the inorganic inert material. So based on the amount of weight loss that has occurred during this process, you can you can get the amount of organic content in the soil only. So but we cannot differentiate humus. In order to differentiate humus, you have to test for its humic acid content.
Okay.
So, but
Designation
yeah,
of that, sir?
you are not
Heating at
audible.
four.
Yeah, yeah, it
he-
is a yellow
Heating
one.
at 400 degrees. What is the name of the test?
Yeah, loss of ignition.
Loss of ignition. It
Yeah,
is there in cement also, right?
yeah, it is there in cement. There are several codes that are present
Oh,
to conduct these tests, and they are usually conducted in muffle furnaces.
okay, 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 okay. Sir, sometimes when we ask some questions,
Yeah.
and if you find any literature related that, you can give a link either through here or in your recorded session at the end or whatever maybe,
Okay, sure, sure.
so that
From
we
next week,
further.
I will add relevant literature,
Hmm,
uh, both publication as
humus.
well as quotes.
Yes, sir. Even in my problem solving session, I asked one question
Yeah.
about Warwood clay. You can also go through. You are having access to the our questionnaire, sir,
Uh, which during lectures.
during lecture. Otherwise, even we have the heading on the top when we see the NPTEL videos and everything.
Yeah, that we can
Question.
access. Yeah.
Then you can go through that, sir. I asked one question about valved clay.
Okay.
I just go through, and if you find any relevant message or
So
answer, even
actually
XRD I asked.
we go through it periodically. So when we go through, we will those questions we will wait for some 2 3 questions to come combinedly, and then we will answer. No issues.
Fine, sir, no problem. We will wait for that.
So, but it will be answered.
Yeah, it's okay, sir. You can send some link also about XRD, Warwood
Yeah.
clay.
Sure.
Thank you, sir. Go ahead, sir.
So now coming to the next question, which of the following is a pozzolanic material? Which of the following is a pozzolanic material? Shales, volcanic ash, quartzite, limestone. So which of the following is a pozzolanic material?
Option B, sir.
Okay. Uh, Now let me ask one more question. What is how will we define a pozzolanic material?
It's a material. Initially, you don't have any binding nature, but in a small amount of lime, it behaves like a binding material.
Yeah. So essentially, the ultimate aspect of pozzolanic material is its cementing capacity, cementing its ability to act as a cementing agent. So
Sure.
that's why these are favored in cement manufacturings and several other uh, uh, where there is a need for cementitious materials to uh, where there are some industries where cementitious materials are favored. So uh, pozzolana itself is a name for a volcanic ash, which is essentially placed in Italy or Europe, I think. I don't remember clearly. So the pozzolana itself is derived from uh, that that particular region where the uh, the deposits from the volcanic eruptions contain this cementitious property. So uh, so among these, shales are essentially clay minerals. Quartzite is crystalline, and limestone is sedimentary. So as far as calcium carbonate is concerned, powders, that is different story. But limestone also contains calcium carbonate, but not there is a difference between limestone and a calcium carbonate powder. So the option will be volcanic ash. Hope I'm clear.
Yes, sir.
Now moving to the next question, question 11. Metamorphic rock that is formed as a result of high pressure is metamorphic rock that is formed as a result of high pressure is option A granite, option B marble, option C shale, option D basalt.
Marble.
Okay, so out of this, marble is a uh, what type of rock? It is a metamorphic rock, right?
Metamorphic rock.
So what about granite?
Granite, basalt, igneous.
Igneous. Shale is
Sedimentary.
shale is
Shale is
sedimentary.
sedimentary rock.
Yes, shale is sedimentary. So now let me extend this question. So granite and basalt are igneous, but what is the difference between granite and basalt? Where they differ from each other?
Rate of cooling, and maybe one is extrusive and intrusive.
Yeah. So granite and the primary difference is that the crystallinity of the grains in granite and basalt. So since granite cools over a very large period of time and it is found at a relatively uh, larger depth, the rate of cooling is very slow. So that cases granite is formed. And if you take basalt, basalt is a result of a rapid cooling. So that is why uh, if you consider the western part of India, so now western in the sense the Deccan region. So essentially, it was a volcanic region before. So several uh, several events of volcanic eruptions and the uh, deposition of magma, and since it comes to the surface, it gets cooled faster, unlike granite. So that resulted in the formation of basaltic formations in the Deccan Plateau region and some uh, in and around the Deccan Plateau region. So the major difference in granite and basalt is that as one of the learners rightly mentioned, it is the rate of cooling and which results in the difference in the nature of grains. So it is more crystalline and basalt is less crystalline and it tends to be amorphous. The grains tends to be amorphous. So that is the difference between granite and basalt. So shale is obviously sedimentary, which is deposits of clay, which is subjected to high cohesion and compaction. And marble is metamorphic due to the result of high pressure and temperature. So coming to the next question, which of the following is a freshwater lake deposit? Option A alluvial, option B loess, option C tuff, and option D lacustrine. Which of the following is a freshwater lake deposit? Option A alluvial, option B loess, option C tuff, and option D lacustrine.
D, sir.
Yeah. So the option is lacustrine. So as the name itself suggests, it is lac is derived from lake. So it is lacustrine. Loess is uh, uh,
Wind blown.
wind blown. Alluvial is water, but it is in
River
moving
transport.
water. Yeah. So coming to the next question, thixotropic property is exhibited by the property thixotropic property is exhibited by option A illite, option B halesite, option C kaolinite, and option D bentonite.
D, bentonites.
So although all are clay minerals, so bentonite specifically, especially it exhibits thixotropic property. So now we can understand what is thixotropy. So to an extent, so uh, thixotropy, as far as ASTM codes, so American uh, system of testing materials, ASTM codes. So the thixotropic property is defined as the property of a material that enables it to stiffen in a relatively short time on standing, that is allowing to without any disturbance, but upon agitation or manipulation to change to a very soft consistency or a fluid of high viscosity, the process being completely reversible. So now this entire sentence can be visualized in the form of a graph. So now if you see this graph, so the x-axis is time and the y-axis is its strength, that is shear strength. Now since when there are 1, 2, 3 and 4 stages that is being shown here. So now unless the soil is disturbed, that is still the soil is undisturbed, its strength is not varying, right? So now when we are remolding it, remolding in the sense it is similar to agitation or manipulation. So this is essentially remolding. In this case, its strength drastically decreases and it starts to, in case of bentonite, it starts to behave as a fluid. And if you leave that fluid undisturbed for some time again, so it will slowly regain its strength and it achieves its original strength. There will be no hysteresis in strength. It will achieve its original strength. And again, when you remold it, it will lose its strength. And again, if you leave it, it will regain its strength. So this is a typical property which of especially bentonite, which we are discussing, which comes into which favors various applications. So bentonites are favored for making slurries during deep drillings. So they are used as a drilling fluid itself. So uh, wherever there are slurry applications, bentonite is more favored due to this properties. Am I clear?
Yes, sir.
So and
Sir, it is with the same moisture content, right?
yeah.
Okay.
At the same moisture content. Uh, that is the point.
Yeah, in the graph, there is no place to accommodate that moisture
Yeah.
content.
So in the presence of same moisture content, that will be uh, uh, when you start applying when you remold it, or when you in the layman form, if when you disturb it, it will start uh, behaving like a fluid. Uh, it will start to behave as a slurry. So and I
Sir,
think
there are.
yeah
Yes, sir. Please continue, sir. I will ask afterwards.
yeah. Tell me. I was about to go
Uh,
to the next question. Yeah
there are 2 points I need to update here.
yeah.
One is about how many cycles it's possible. Is it one or two, or do you have any limit of the cycles? For
No,
example, you are disturbing these for 10 times, 20 times, 30 times. Will it
mm,
come back original strength or not?
mm. So uh, when you are doing it repeatedly, it may lose strength over a period of time, but not with 1 or 2 cycles. So but when you are doing it, and that's why they will to the best of my knowledge, they will change the bentonite slurry after some of the cycles.
Okay.
So I'm not sure how many cycles exactly these take, but uh, 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 slightly I remember that they get changed over a period of time as far as
Yes, sir.
actual
In pile
fields are concerned.
foundation, in pile foundations.
Anywhere where drilling is being carried out.
That is one of the answer for that replacement of the bentonite slurry or changing is because of dilution of
Yeah,
water.
yeah,
Uh, my second question is
yeah.
in the same. This is only just to update knowledge. That's all, not for anything.
No, you can
The,
go ahead.
the second question is the remolding is only man-made or natural also possible?
No, its rebounding is completely natural.
No, sir, not rebounding, remolding, vertical
Remolding.
graph,
Yeah,
vertical down.
okay. Remolding. I thought it was
Mm.
rebounding. So,
No, no, sir.
Uh,
Remolding.
Remolding, it is since the rapid amount of uh, remolding is not possible in a natural way. So, it here the exact meaning is man-made action.
Okay. Disturbance. Any
Yeah,
kind of
disturbance,
disturbance.
external disturbances.
Okay. That is why it is vertical
Yeah,
without
that is
occupying X
immediate.
axis.
Yeah,
Immediate. If it is natural, it takes just like a slope.
yeah. And also there will not be, and since it is time dependent, uh, uh, there will be a cycle of losing, regaining, losing, regaining. That
Mm,
cycle will be within this the slope you are mentioning itself.
mm,
So it since it is moment that is impact that is similar to impact loading, what we can say to give a analogy, or sudden loading, so that
mm.
it results in a very immediate loss instant.
Okay, okay, okay. It's like a drilling the casings and all those will be
Yeah,
normally
yeah,
makes a
yeah,
sudden disturbance. Okay,
yeah,
okay. And similarly, sir,
yeah,
bentonite and black cotton soil normally in SAR lecture also they say it is a cousin brothers, something like that.
yeah.
When we have a bentonite thixotropic property, is
Hmm.
a BC soils also will have say at least some extent thixotropy,
No,
black cotton
no.
soils.
Here, as far as uh, SARS contact is context was in terms of
Mineralogy.
its mineralogy as well as in terms of its swelling shrinkage properties.
Okay, okay. From thixotropy point of view, these two are independent.
In maybe montmorillonite also possess to an extent, but not as predominant as bentonite.
Yes, sir. That may be reason nobody will use the black cotton soil anywhere.
Yeah,
Bentonite will be popular.
yeah.
Yeah. Thank you, sir. Thank you for discussion.
So
Okay.
now moving to the next question. Black cotton soil deposits are formed from weathering of
Result.
basalt. So now you can relate why black cotton soil is found in the western regions. So if you take the chronology, so the Deccan Plateau was once more active volcanic regions. So it resulted in the formation of volcanic deposits, which results in rapid cooling. They form basalt, and basalt undergoes chemical weathering to give black cotton soil. So this is the reason why we find black cotton soils in the predominantly in the western part of India, especially in Maharashtra, uh, some part of Karnataka as well. So I hope it is clear now, right? So as far as
Yes, sir.
these are concerned, granite is granitic gneiss or igneous, and shale is sedimentary. So those are obviously not. That is, granitic gneiss are essentially due to the slower rate of cooling, and shale is obviously a sedimentary rock, uh, which on this disintegration forms clay. This only clay minerals of various varied mineralogy, not essentially black cotton cells. And coming to the next question, which of the following deposits is susceptible for liquefaction? Which of the following deposits is susceptible for liquefaction?
Sir, can you zoom the font size a little bit?
Okay, okay,
Is
just
it possible?
yeah, yeah. Mm.
Yeah, now it is fine, sir.
Which of the following deposits is susceptible to liquefaction?
Option A, sir.
Option A, alluvial, clay, laterite, peats. So why it is alluvial?
One is they're completely washed material. You don't have a binder.
Yes.
Shear strength normally proportional to the sea and 5.
Yeah.
C will be 0 for the soils.
Mm-hmm.
And second one is due to the any kind of vibrations created by pile driving or earthquakes or something momentary.
Okay.
The pore water pressure build up and increases the pore pressure and decreases the effective stress.
Effective stress. And
And effective
that
stress
is
once
that is
yes, sir.
further
Hmm.
which many people would not understand here. So
Hmm.
major reason is its uniform particle size.
Okay.
So that is the reason they are mostly loosely graded material. So when loosely graded material are subjected to very high momentary pore pressures, they get liquefied. So alluvial deposits, if you take a particular cross section of a region, um, uh, since most you leave out the flooding period. So apart from that, mostly the river deposits are fairly uniform, which results in a fairly uniform size of the grains. So there will not be much difference in the
Size
distribution
of
of
the part. Yeah.
distribution of the sizes. So which
Hmm.
results in a loosely deposited loose deposits. There will be if you consider a soil sample with varied particle size, there will be a good packing between these particles, and when you consider uniform particle size, there will be the packing will be very loose. So that is the reason they are subjected to liquefaction. So liquefaction, to the people who are not familiar, so I will give you a broad brief idea of what is liquefaction. So liquefaction is, if you put it in a layman terms, soil will be behave as a liquid, so it does not have any strength. So when you place your leg, or if you place your leg, it will you will not be you will not uh, you will not be able to stand. You will be it behaves as a liquid. There will be no shear strength. So that is where the as for the present, that is sufficient. You will learn as the course progresses what is liquefaction and everything. So liquefaction is due to the loss of shear strength of the soil. Hope I'm clear now, right?
It's clear, sir, but still a small query.
Yeah, yeah.
Is it not possible for mixed soil? You are saying uniform soils is probably liquefaction occurs,
Yeah,
but if the
actually,
soil,
so I understood. To to clarify your question, so
hmm,
here susceptible in the sense, if you consider uniform sizes, so there will be relatively loose. They are
okay,
poorly graded, which results in a relatively lower density.
okay, sir,
So that is the reason they are more susceptible. They are relatively susceptible to liquefaction.
okay, okay. So if the option is given uniform and non-uniform, the option goes to the uniform soils.
Uniform.
Okay, right, sir.
So now coming to the next question, it is a match the following question. So left column provides the uh, transporting agents, and right column the corresponding deposits. So wind is, we have discussed a lot of times, it is lowest. Lake, it is already in the previous uh, some questions before we have discussed, it is lacustrine. gravity it is talus, and glacier it is till. So the deposits that are formed due to uh, glacial action is till. Those are left behind when the glacier gets melted. Those are till. Any doubts?
5 doesn't match, sir. It is a surplus.
It is a surplus to just
Okay.
confuse.
Okay. Okay.
So moving to the next question. So here the left side left column specifies the type, specifies several uh, rocks, and right side is the uh, classification, geological classification. So limestone is sedimentary, shale is sedimentary, granite is obviously igneous, and marble is metamorphic.
Madam.
I think it is fairly straightforward, right?
Yes, sir.
So now coming to the last question. So this left column specifies several type of deposits, and the right column specifies the regions where they are formed or similar to that. So first option is loess. Loess is formed in semi-arid regions, especially in partial deserts. Residual is muskeg. Transported soil is alluvial, and peats are essentially organic content, organic matter. Hope it is clear now, right?
Yes, sir.
So with this, the questions for this session is completed. So these sessions are recorded and it will be uploaded in the NPTEL this also. It will be available in the public forum also. So and this session will undergo we will be uh, as you might have seen in NPTEL website, right? So it occurs every Saturday 5 to 7. There will be no change in timings or the day which it occurs. Uh, so that's all for this week. Thank you for attending, and see you next week.
Thank you, sir. Thank you very
Thank
much.
you.